Previously, we looked at this relationship where the wavelength times the index of refraction of one material is equal to the wavelength times the index of refraction of another material. And if material 1 is vacuum, then the index of refraction of vacuum is 1, and the wavelength in vacuum we represent as lambda naught. We can solve that to define the index of refraction as being the ratio of the wavelength in a vacuum divided by the wavelength of light in a material. Now, this index of refraction depends on the wavelength. So the shorter wavelengths are actually bent more by traveling from one material to the other than longer wavelengths. And that means if the index of refraction depends on the wavelength, that different wavelengths are going to be refracted at different angles. And this leads to the phenomenon of dispersion, and is how prisms work and are able to send different colors of light in different directions. So if we look at how one wavelength travels through a prism, the wavelength will encounter the boundary between the prism and the air, and it will be bent towards the normal. Then as the light exits, it's bent away from the normal, which actually ends up bending the light still further. If we look at the angle between the direction that the light was originally going and the direction that the light is emerging from the prism, this is known as the angle of dispersion. If you have two different wavelengths, they will be bent by different amounts, and a shorter wavelength will have a larger angle of dispersion. It will be bent more at both of the interfaces, whereas a longer wavelength, such as with red light, will be bent by smaller amounts and will have a smaller angle of dispersion. So these two rays of light, one red and one blue or purple, will exit the prism at different angles, have different angles of dispersion, and that's how prisms are able to split white light up into their various components by wavelengths or colors. Now, rainbows are made when you have droplets of water hanging in the atmosphere from rain, and these droplets act like prisms. So if you think about the light coming from the sun, the light coming from the sun will enter the water droplet, and the different colors will be refracted by different amounts. The light then reflects off the back of the raindrop. Some of it will be transmitted it back into the air, but some of it will reflect, and then it will emerge from the raindrop with different angles of dispersion. So if you're standing there on a rainy day with the sun behind you, so if the sun peeks out from the clouds and is bright behind you, you can look in the direction away from the sun. Now, the light that is, the red light is coming out with this greater angle of dispersion here because of the reflection. We have this angle of dispersion for the red light, and so you see red higher up than you see the purple and the blue light. And so the light appears to be segmented into colors, and you see the colors of the rainbow appear. Now, if you're up high, like in an airplane, you can see the full 360 of a rainbow, and you can sometimes even see a double rainbow, which is caused by the light having two reflections on the back of the raindrop. And that's why the second rainbow is always fainter than the first, because each of those reflections gives an opportunity for some of the light to escape out the back of the raindrop. So next, let's consider this question. Let's suppose you're told that only two colors of light, X and Y, are sent through a glass prism, and that X is bent more than Y. Which color travels more slowly in the prism?